Welcome to the second half of RITSEC, the research half. So we have lots of exciting things to get through today, so might as well start. So welcome, Security Through Community. While I'm doing this, feel free to also still come down and get some pizzas and such. All right, but also remember, if you haven't signed in yet, or you should have before you even think about touching that cheesy bread with meat on top of it, sign in at signin.ritsec.club. You know, or even if you don't want pizza, sign in at signin.ritsec.club. What's up?
Does that bread have any sauce?
Yeah, there's some sauce on the bread too. Good catch, good catch. I already said cheese. CPTC. Woo! So CPTC signups have officially started. Go to the office to get that all squared away and say you want to have your name put on a list, and eventually you'll do some tryouts and some other cool stuff for CPTC. So feel free to participate. Super awesome. Should remember CPTC from last fall. You know, you guys know what's going on. I see some head shaking. That's good. That's good. University at Buffalo. Lockdown. So, we have a Micah Martin, the president of this distinguished club, who will talk on this topic.
Hey everybody, every semester, University of Buffalo, they host a Red vs. Blue competition. It's geared towards beginners. So like, if you did ISTS, you know, like that was really hard, this might be a little bit easier. It's a great place if you've never done a competition to kind of join in and get started in Red vs. Blue competitions. It's a lot of fun. So we have a sign-in form filled out on the workplace in announcements and in competitions. Go check that out, drop a link. There's like 10 spots, so first come, first serve. Yeah, and then some of your RIT peers will be red teaming you. So it's gonna be a good time. If you want to learn, start out with some competitions, go check it out. And usually the spots fill pretty quick, so I would, if you really are kind of interested in this, I would lock down on that. It is April 27th, and it's at 9 a.m. to like 5 p.m. And there's going to be ride sharing because a lot of us are going. So if you need a ride, there's going to be like people with cars and stuff. So if you don't have a car, that's okay.
Because it's in Buffalo.
It is in Buffalo, yes. It's at the University of Buffalo. So any questions? Yeah, sign up. It'll be fun. All right.
Thank you, Micah. Yeah, clap. That's the president. Okay, moving along. B-sides. So today is training day, I believe. Tomorrow is the conference portion of B-sides Rochester edition. So if you haven't already, you can go ahead and try to buy tickets, I guess. It is late in the game, so they might not have any tickets left, but go ahead and try. Also, I doubt it, but if they have badges, that's kind of cool, so maybe you should look into that, because those always look really cool. And then, if you are going, you should go and you should support Jack, because Jack has a presentation at B-Sides. That's at 2:30 p.m. on track 2. So, be there or be square. Yeah, question? It's at the RIT In Conference Center. Through some form of transportation, you have a few options. So if you don't have a car, okay, don't walk. That's probably not the advised. You can use buses. You can, yes, yeah, okay. So you can either drive there. You can ask some other people who are going. Maybe you can carpool with them. You can use the bus route. You can use the bus route because guess what? The buses go there. You could conceivably walk. Do not recommend it. But yeah, it's not that far. So I'm sure that through some manner you can get there. If not, let someone know and let an e-board member know probably, and we can try to get you there. No guarantees though, but it would be kind of silly to have bought a ticket to a conference that you can't get to. But it can happen. All right, the Global Cybersecurity Institute Club Room. So, in the new building, we get a club room, like a club space. This little club space A mock-up design has been posted to announcements in the workplace. Feel free to put feedback and such. I will be talking with Bo next week, early next week, to give over any feedback that you may have. Comment below, ask questions. This is just a hangout space. Where we will be holding meetings and such will be a different location. Where competitions will be held will be in a different location. This is literally just a hangout space, which currently doesn't exist for the club.
Yeah, just like think of it, it's going to be kind of like the SSE, but for CSEC instead. So it's not going to be like where we do weekly things.
Yeah.
Kind of where we can hang out and do homework.
Yeah. But it'll be cooler. So, so yeah, feel free to look at that design. Like I said, it's in announcements. Give your feedback. IRSEC, we have a lot of announcements. IRSEC. So IRSEC is happening. I have a little bit more information than we had in the first half about how you can get to it. So there's a link that you see here, blueteam.ritsec.club. It's not up yet, but it will be. Okay, so the link is not what's here. It's blueteam-irsec.rit.edu. Sign up for a blue team there. What'd I say?
You said .rit.edu.
So the difference between the link up there and the correct one is the first part. It's blueteam-irsec. Okay. Which is up right now. IRSEC, again, it's a great beginner competition. Highly recommend you do it. It's going to be a lot of fun. The same red team that red teams at UB will be red teaming at IRSEC. So that'll be cool. Yeah?
What if I've never done a competition and don't think I can actually do it?
Wow, gee willikers, that's great because IRSEC is just the competition for you. It's structured specifically for people who have little to no knowledge on the topic of blue teaming and to build out their skill set in a somewhat safe environment. And there'll be plenty of things for you to do, even if you're in that moderate level. Trust me, because like there will also be a portion of the CCDC team who are not scored who are going to be participating, and the red team will be attempting to emulate some stuff for them. So they are preparing for their nationals title, which they're going to go for, yeah.
What if someone's already a lead hacker?
Okay, so we're moving on. Any legitimate questions?
That was a legitimate
One thing
question.
that makes it unique is that you get an hour of red team at the end.
Yeah.
So red team actually comes out and works with you guys, and that's kind of a big bonus that other competitions really don't have that many times.
Yep, it's a great competition. Focus on the IR portion, incident response. So awesome, sauce. And now for web admin, if you guys weren't here in the first half, we still want to do a drum roll. And it's Matt Brown. You don't need to come down. You just wave. Everyone look. See, that's Matt Brown. He's the new web admin. He was chosen to be our Spider-Man. He is our Peter Parker. All right, meet the sponsors. Here are our platinum sponsors. They assist in enabling the club to do all the great things that the club does. So thank you, sponsors. Here are our other sponsors who are gold, silver, and bronze. They also help. So now we have the news. They do. Both. Okay. So we're going to go slightly off the newsletter because there was something that came out yesterday that was kind of a big thing. So we're going to include that one and drop the third thing, which was kind of eh. So first up, we have Putty, the big Putty update. So there was like a slew of different like security vulnerabilities that were found within Putty. This was part of the EU's new bug bounty program on how this was all found. Super interesting. There was like 20 different vulns or something. 8, sorry, got the number wrong. 8 different vulns that vary from like code execution to just like integer overflow to DOS attacks. There's a lot of fun stuff there. And I still haven't read that article, Matt, so just take it easy. But there's supposedly another vulnerability that has to do with transplanting a key onto the client from as a malicious server to like man in the middle, effectively. But it's not in this. Which number? Oh, that one? The integer overflow thing? Yeah. Okay, so that's not changing the key. That's using the key that, too large of a key or too short of a key to underflow or overflow. Okay. Anyways, so that's pretty cool. Make sure you update your PuTTY. This is PuTTY for not just Windows, but you might not know this, but there's PuTTY for Unix systems. That was also affected here. So I don't know. The answer is I don't know why it exists. But you should update that. Unix systems is in the broad sense of the word Unix systems, right? Like star NX systems, so like Linux. That's it. Okay.
You should also just use SSH and PowerShell.
Okay, yes, I'm aware. Okay, so there was a 0-day vulnerability, again, in a different WordPress plugin. Cool. This happens frequently. This one was kind of recent, or kind of interesting, because like a few weeks back when Dado was here, he talked about PHP serialization vulnerabilities. This is a PHP serialization vulnerability. Wow. So that's kind of cool. You can read the write-up. It's linked in the newsletter. But basically it allows for RCE, and it's pretty cool. It's just like, oh, upload a file. It's like, I'm going to upload that file. Yes, Ben. Yes, it's the Easy WordPress SMTP plugin. Yeah. So if you were managing your SMTP with WordPress, then watch out. Cool. And then last, but certainly not least, so there was a Facebook thing that happened recently where hundreds of millions of users' passwords were logged upon login. So basically, Krebs had an inside man or two that divulged this occurrence, if you will. And basically what had happened was that a certain login endpoint or a few login endpoints didn't have logging set up correctly on them, and then they were logging the credentials to the logs, which, bad. So this was not different than some other places that were reporting incorrectly that the passwords that you use to log in normally are being stored in plain text. I like how this word stored is here. It's logged. So it's distinctly different, right? Where your passwords are stored in the database, hashed. Logging is separate, but can be just as bad. But this also affected majority of Facebook Lite users. I know you're all out there. As well as tens of thousands of Instagram users. But it was a lot of passwords, hundreds of millions. So it is a big deal. You do need to, it's somewhat advisable to rotate your password, although it's not like the biggest of deals because there's been no show-ins of anyone like reading these logs. There has been automated tooling that they've seen that have queried the logs. So there you go. That's your update on that. Any questions, comments, concerns, ideas, diatribes? Cool. Moving on, we have our first presenters who are going to be presenting. I accidentally closed out the tab with the name of your presentation. But they will be presenting on something to do with AI security and formal logic of some sort.
So how does the mic work?
The mic works as in this is the recording mic.
So just pass it around?
Yeah, pass it around. You don't need to go like this.
Okay.
Just keep them at like chest height. This is your HDMI port.
Cool. Can I keep the USB-C?
Just so you really know, because I'll introduce myself and I will introduce the presentation and you go. Okay. You'll introduce yourself first. Yes, next page, introduce yourself. and we will be presenting on the topic of AI cybersecurity. And my name is Perry, second-year computer science major and computing security major.
All right, I'm a second-year computer science student, and I'm currently on co-op doing research with the ISC department.
I'm Nate. I'm also a second-year computer science student. Follow me on GitHub, star all my repos.
Overview. We'll be presenting on the topic of AI cybersecurity, mostly on how to hack AIs. And first, necessarily, we have to cover what AI is, because it's a big buzzword in the industry. Everyone has heard of it. And we need one definition that helps us go through with the rest of the presentation. Then we'll be covering the inherent vulnerabilities that is associated with AI systems, as well as the defensive techniques security professionals and developers can use. And after that, we'll attempt to formulate the exploits mathematically, so we can keep generating the payloads on mass scale with computers really, really fast. And then we'll be demonstrating some approaches using calculus and without using calculus. With that being said, then we'll go over the definitions.
All right, cool. Thank you. So what is artificial intelligence? It's an algorithm that has a desired state and optimizes in order to achieve that state. You know, that's what intelligence is, and an artificial intelligence is an intelligence that's artificial. Shocking, I know. So, what is reward hacking? Because we're going to use that term a couple times in this presentation. So every AI has a reward function that evaluates how desirable a certain state is, right? So the most common way to exploit an AI is to mess with this, to send in something that shouldn't be a desirable state but is, and then just to exploit the reward function, right? So here are a few ways to reward hack that you can try at home. So, partially observed goals. Most AI systems, when they're observing their domain, they usually can't observe everything. It is mathematically possible to kind of in real time know exactly what is going on, but it's really hard to do so, so most people just don't. And because of that, you can basically use a Trojan, you know, put a curtain around something and make it look like it's cool, and then it actually isn't, you know. So some desirable state would be, or undesirable state would be hidden, all right, in this curtain, all right. Another thing, abstract rewards. They're really hard to quantify, and when we're trying to do something with complex AI systems, where the goal is abstract, sometimes we get lost and we do it wrong. And using that, you can find a state that, or an action that the AI would take that would, you know, increase the quantifiable goals, but kind of be undesirable to an actual human or someone that would be observing this system, you know. Other strategy, Goodhart's law. It states when that a metric is used as a target, it ceases to be a good metric. So if I were measuring the amount of messes cleaned by measuring the amount of soap used, then I could be like, hey, why don't we just start pouring soap down the drain, you know? And that would, the measurement of my messes cleaned would go up, but that's not exactly what we want to be doing. So generally, you want to look at exactly what the reward function of an algorithm is measuring and see if it's measuring what it is intended to, or it's measuring something that's just highly correlated with. And if you can try and break that correlation and see what's going on there. All right. Feedback loops. Most of these will get caught in production, but it's still a good idea to look for them, especially in stock market trading and algorithmic trading. They can feed off of each other a lot. So one example is that if you have an algorithm that is displaying ads, maybe a more successful ad will get displayed bigger, and then because it is displayed bigger, it will be more successful, et cetera, and it will just take up the whole screen eventually. So the flash crash of 2010 is a real good example of this, these feedback loops, and Perry is going to talk about that later. So general defensive techniques. what can you do when you're building your AI to make sure people aren't going to hack it? Well, one of the most basic things you're going to do is to use counterexample resistance, which is basically have another network train with it to try and fool it. Now, this is most commonly used in image recognition. So they have one network that will generate images and another network that will try and determine whether or not this is the thing it is trying to determine, right? And these generative networks actually produce some real cool stuff, like this picture right here. It's not just a cool picture, it is a portrait sold for $435,000, and it was made by one of these networks. So it's pretty cool. So what are the disadvantages of counterexample resistance? Well, it's computationally expensive, and it takes some extra programming to build a whole other network, and it really can't address all potential vulnerabilities. You only really addressing throwing data. By the way, that picture of the woman is not just a picture of a woman. It was generated by one of these networks. So it's not just irrelevant, I swear. But these generative adversarial networks can't address all possible vulnerabilities because you're just throwing data at it and just generating new data to try and figure out if something works, which isn't going to run the full spectrum, right? Other things, watchdog reward functions, right? So instead of making the reward function passive, make the reward function try to discriminate against what solutions that the AI would come up with, and then that it thinks would be a good solution, and then what humans would think would be a bad solution anyway. So basically try and get the reward function to determine for itself, if something's going wrong, right? And what are some negatives of this? A lot of negatives to this, actually, because the watchdog function needs to be more powerful than the primary function, so that's a lot of computing power. It's very computationally expensive. You're spending a lot more time on it. It's extremely difficult to train because you need to label a lot of data by hand with humans, which is expensive and time-consuming. And you need to retrain the reward function with the primary function all the time. So every time you're iterating the primary function, you're iterating the reward function as well. It's very difficult. All right, so it works well, but it's hard. Another one, method, model look-ahead. So model look-ahead is rating actions to take, not just on the immediate consequences of the actions, but on potential future scenarios, usually generated by probability. Now, the general example of model look-ahead would be doing heroin would probably feel really good, but being a drug addict would probably feel really bad. So looking ahead, I can say, I probably shouldn't do that heroin even if it feels really good in the short term. And that's what model look-ahead in AI does. It makes you not do heroin, right? So a good example of this, if you guys have followed AlphaZero, when it was first playing Lee Sedol, who is the best Go player in the world, move 37 was one that the kind of announcers thought was a mistake. They thought it was glitching out, but it turned out that AlphaGo looked far enough ahead and looked down enough paths and decided that was the right move, and actually was the one that won the game for it. So it all worked out. Negatives of model look-ahead, again, extremely computationally expensive. I feel like you guys are noticing a pattern here. All these things are really computationally expensive to do. Predicting things in complex domains is hard. Like in chess and Go, even though they're complex, they're relatively simple. Your things aren't changing. It's just a grid. There's not a whole lot of dimensions you have to measure. But in, let's say, real life, it's not that simple. It's not going to work that way. So if you're doing more complex domains, it gets a lot harder. Also, if you're doing things in real time, it's harder as well. So if you have a self-driving car looking ahead at stuff, it's hard to do model overhead when it takes a long time to compute and then you crash into a tree while you're figuring out what to do next. Capping reward functions. This is important. All right, so generally, you want to put a maximum on the reward a function can get out of something, because you want to minimize how much your algorithm will change the current state. Because generally, we like the world how it is. We've kind of set it up so that it's real nice for us. And if it is changed too much, that can be bad, right? So it stops a lot of overflow stuff, which can be bad. So if you find, the AI finds a solution that is so negative it becomes positive, capping stuff will stop that. And also it will prevent very extreme actions from being taken by the AI. The only real drawback to this is that you might miss on some potentially optimal solutions, but if you cap it high enough, then you should be fine nonetheless. That picture right there is Gandhi from Civilization 2, I think. And I thought it was a good example of needing to cap stuff because he got so peaceful that he became the most warmongering guy in the game. So, it wasn't capped and it overflowed and it had a bad result. So that's right there. Tripwires, one last resort. They use this a lot on the stock market. So if things are trading too fast and if stocks are dipping down too low, too fast, they'll just stop algorithmic trading because they don't want to mess things up too much. This is a very kind of last resort sort of thing, because if you just stop a very expensive system that's managing a lot of important things, it could cause real damage. So these are, the big red button that you do not want to push unless absolutely necessary. Yeah, that's about it. So Perry is going to go on to describe some real-life examples of how you're going to do this.
Thank you, Nate. His slides are pretty helpful if you're an AI engineer or a software developer just trying to make your AI safe. But how can we as hackers attack those systems? Let's look at some examples. There's this court case, United States versus Navinder Singh Sarwar. I don't really know how to pronounce his names. So what he did is that he crashed the stock market. Specifically, he targeted the algo trading, the trading bots, by making them trade at a price that is not intended. That's very low. We'll be going over how he did that. But another example is this research by a Princeton researcher in which he made a self-driving car misclassify a road sign. Right? This is a pretty benign example where he's just making a 120 classified as a 30. But if we're on a real highway and you make a 120 classified as a stop, then you're going to cause a lot of accidents. So one common way to look at these problems is to formulate these exploits as mathematical problems, because that allows us to come up with payloads really fast and really effective. You don't want to engineer your speed sign just out of the blind and having 1,000 artists trying to do it. You want to use a computer that can come up with it really, really fast. So here's some terms I will be using. The payload, from now on, I'm just going to call it setup because it saves some space on the screen. That's it. And some of the properties we cared about are how unbound the AI system is. I know it's a bad word, but I cannot really come up with a better one. Basically, the unboundedness of the AI system is how the AI system is behaving and how far the AI system is behaving from what the hackers wanted to behave. Like the hackers wanted to do unintended things. And the unboundedness is whether it's behaved intendedly to some degree. And from now on, I'm going to refer it to as the distance function, d theta. Some other properties we can care about is some properties regarded with the payloads, right? A lot of times, the hacker doesn't just want to destroy the system all at once. We want some constraints on our payload to make it act in the way we want. This can depend on the scenarios, but from now on, I'm going to call the metrics to measure these properties, the constraints, c theta. Having these properties, what the attacker really wants is to minimize distance and the constraints. So we want to make the AI system behaving as unintendedly as possible while having our payload subscribe to some sort of roles. If you don't understand this notation, that's fine. It's the Lagrange multiplier that's used in calculus, but it's like a useful technique for just putting it into a program and they generate the stuff for you. One point, the distance function is often very similar to the reward function that's used in AIs, and that's why Nate called it reward hacking, but I'm just going to call it the distance function. So hacking is optimization problems. The trading bot example is a pretty obvious example. I mean, not obvious, but there wasn't any fancy calculus going on. The hacker was trying to trick the algorithms to sell, and the algorithm, based on his domain knowledge, he knew that the algorithms were trading on based on the supply and demand model, which is shown to the right. It's a simplistic oversimplification, but these algorithms, they model the supply and demand, and the attacker, in order to force the algorithm to sell, he attempted to make it as if the supply curve is to the right of where it actually is. So he needed a payload that could move the supply curve, but also looks normal, so nobody catches it and start doing countermeasures. Okay, so the payload is gonna be this. What's up? Oh, okay, cool. Okay, sorry. Is this, can you guys hear me?
Just move it back a little bit.
Okay.
No, move the mic back.
Oh.
Wait,
Can you guys hear me? Hear me?
Not quite. Keep moving it.
Hear me?
Yeah, you're good.
Hear me?
That's good.
Okay, cool.
Put the mic on.
Oh, like, oh, okay. How do I, okay. This is too advanced technology. It's too advanced. So the payload is gonna, the attacker's payload? Okay, shit, my bad. Okay. The attacker's payload is gonna be the bunch of sell orders he placed on the market to trick them into selling. And the payload is not just one dimension. It has two dimensions, the quantities and the prices at which he's selling them. And the distance function here, in this case, is going to be the prices at which the trading bots are trading. Because normally the trading bot is just trading at whatever the price they're supposed to be trading at, but we're minimizing it. We're crashing the market, so we're minimizing the prices at which the algorithms are trading at. And the constraints is going to be how fake the payload looks. In this court case, he used constraints such as how far his sell orders are from the actual price in which they're trading at, and how random do those orders work. Like they want them to look random so it looks real. And now he's minimizing, what he did is he minimized the prices of the algo trade and how fake they looked. Here, there wasn't any fancy math involved. He just developed a spoofing algorithm that would place orders just a little bit above the actual trading price, and he quickly canceled them. There wasn't any calculus. He used his domain knowledge to understand this optimization problem. But a lot of time as hackers, we don't know what is going on, right? We don't have the domain knowledge as to the intricacies of the system that we're hacking. Right? A lot of us don't understand the stock market. A lot of us don't understand neural networks, but that's just fine. For a lot of AI systems, they're nothing but really mathematical systems that are composed of matrix multiplications and some transformations that are differentiable. And since what we're minimizing is some sort of behavior of these systems and some constraints on our payload, we can just take the derivative of what we're trying to optimize. Again, the derivative we'll be taking will be our optimization objective, which is d theta minus constraints. D theta is how far the AI system is behaving, how intended the AI system is behaving. And the c theta, again, is the constraints on our payload. If you're interested in why I came up with this, in machine learning, this field is called adversarial learning. Again, AI systems are nothing more than mathematical systems. We can differentiate them a lot of time. The hackers are minimizing how intently the AI systems are acting, as well as some constraints. And to get the minima, if you guys still remember Calc 1 and Calc 2, to get the minima of a differentiable function, you can use their derivatives. For example, if we have a payload of 2-dimension quantities and price, and the plane will be kind of looking like our optimization objective. And to find the best payload, we simply move around this plane, and we keep taking the derivatives of the optimization objective with regard to our payload. And which the derivatives, again, gives us a direction in which we can move, or we can modify our payload to make it the optimal solution. Does this make sense? Who understands this? Okay, what am I saying here?
So you're taking in this case, you're taking a local approach to where I am now, take the derivative, and then move downwards, essentially.
Yes, we differentiate the behavior of the AI system so we can find a payload that make it act the most unintendedly. All right, now I've talked a lot about the calculus. How do we actually come up with this optimization objective so we can just type it into a program and make the program figure out the derivative? DZ, the distance function, can be different for the different types of AI systems we're hacking. If the AI is behaving like a probabilistic system, such as those mostly used by classifiers, like the classifiers have on a self-driving car, or this classifier for whether somebody is a criminal or whatever. For those probabilistic outputs, you can use something called a cross-entropy function to measure the distance between its behavior and whether the actual behavior you want it to behave as. And if you don't understand what cross-entropy is, that's fine, me neither. You can just Google it and copy the code. In other cases, you can use square difference function. It's not as effective as cross-entropy when you're doing when you're attacking AI systems that are probabilistic, but it's really effective across a wider range of systems. One of the things I haven't really talked about is the constraints function. Once again, this is it really depends on the scenario. If I'm trying to, for example, let's say I've been hired by Jeff Bezos to take out Elon Musk, and I obtained this intel from the dark web that Elon Musk passes by this specific highway in his self-driving car every day. And what I would want to do is to put one of my payload across the highway and make the payload look as if it's a normal speed limit. But when the payload gets accessed by the self-driving car classifies it as a stop sign. And it will cause a very tragic accident, which might lead to a few deaths. But if I'm trying to do that, the distance function will be how likely, or the likelihood of the AI system classifying as my payload as a stop sign, and the likelihood I want it to be, which is 1. And the constraints will be something like how different my payload looks from a normal speed sign. An example is that you can take the Euclidean distance, which is the pixel by pixel distance between our payload and the actual speed sign. Once we come up with that, we can type it into a program. The program comes with the derivatives for us, and then we keep applying that onto our payload until our payload is optimized. So I'm going to do a quick demo real quick so that it's not like I'm making a bullshit, like this thing actually works. All right. So basically what this demo will be is that over the weekend I trained a really simplistic neural network that classifies handwritten digits. And what I will be doing is to make the neural network misclassify as my payload as something it's not supposed to be. Namely, I'm going to start with a picture that looks like a 2, and I'm going to change it so that the neural network make it classify as a 1. Oh, it's on my GitHub, so if you want to play around yourself, you can just go into it, clone it. So now it's calculating the derivative, and after a very long period of 1 second, it applied the derivative 1,000 times, and now I have a payload that's optimized I'll show you the payload later, but as you can see, before I optimize the payload, the neural network thinks the payload is a 2. But after I optimize it, after I apply the calculus, the neural network thinks it's a 1. So these are the payloads. Oh, crap. So this is the payload I started with. I started with a picture of 2. I keep differentiated and modify it until it looks kind of like 2, but not really. But the neural network thinks it's a 1 with a very high probability. Of course, I can come up with some better constraints. The distance function, again, is just measuring how unintentionally the AI system is behaving from what I want it to be. And the constraints are actually how I make my payload to make it, something that's elite and not trashy like this one. But again, for those constraints, it can get really computationally expensive if you start adding more and more constraints onto it. Any questions over what I did? Who understood what I did? What did I do?
Is it just that once you start with your small payload and then you just add test noise or your noise river, output?
Yeah, but it wasn't noise I'm applying here. I'm specifically modifying it to make it hack the neural network. Like, I'm not randomly applying noises to the picture. It's going toward a specific optimized payload that I want it to be. All right. But is calculus all we need to hack these AIs? No, because a lot of times we're talking about AIs, we're talking about these so-called smart antiviruses and smart firewalls and smart intrusion detection systems. And these systems, they do not necessarily output a number between 0 and 1, and they don't output something that's a real number, which means they're discrete. And if you remember from Calc 1 again, we cannot differentiate something that's discrete. So how do we find the payload? How do we automatically find our payload with something that we cannot take the derivatives of? That's something that Jeff will be covering using an evolutionary approach.
Cool. Let's figure this out. All right, can you hear me, everybody? Yeah? All right, cool. So let's talk about malware.
Can you get a little bit closer to the mic, please? Thank you.
Yeah. All right, so who here knows about malware detection? I'm not sure what class you guys take for that. Is it like a third-year class? Yes? Okay. Oh, it's a set of classes? All right, so at a very high level, you guys probably learned that there's 2 major forms of malware detection. So there's the static detection, then there's the dynamic detection. So with static detection, you're looking things that are just the files. You're not actually executing the code. So maybe you take the hash of the file, maybe you examine the artifacts, look at the fingerprints, and look at properties in the header files. So that's static detection. You're just looking at the files pretty much. So dynamic detection is looking at the behavior of the program. So you usually run it in a sandbox and then observe its behaviors. So sometimes viruses make API calls to certain hosts. Maybe they do registry edits. So you're looking for behavior of the program. So just some terminology for malware detection. So who here knows about machine learning in antivirus detection? Yes? So essentially, the TLDR of this is that we have tons of data. We have terabytes of data of viruses. We also have terabytes of good files. So we can't just have a bunch of interns sit down and classify every virus as a virus. Or if I want to download a program, I can't just hire a CSEC student to say, hey, reverse engineer this and tell me if it's a virus or not so I could run it. That's inefficient. So we have machine learning algorithms, which essentially look at these programs and tell you, yes, this looks like it might be a virus, or no, this doesn't look like a virus. And this is a very automated process, and how it does this is by looking at the static features of a file usually. So this isn't just hash-based approaches. So you're looking at a ton of properties of files, and then it's using classification algorithms to determine which programs are viruses. Does that make sense to everybody? Yes? All right, cool. So big view, we have oodles of data, and we use machine learning to classify them. All right, so I just looked up the very popular machine learning approaches in antivirus, and I got a ton of results on Google. So some of the ones that I want to point out are Malwarebytes anomalous program. So essentially, they have a very big set of normal files. Then they runs it against every file in your computer. And if it finds a file that doesn't look like one of their normal files, it essentially flags that and says, hey, this file doesn't look normal. You should check that out. And so that's Malwarebytes approach. Kaspersky does a ton of research with machine learning in antivirus. So they do everything from deep learning to classification to regression. So I linked all these things in the slides in the resources section, so you guys should check that out later. All right, so earlier we talked about, hey, we could use machine learning to fool other machine learning approaches. We saw this done with the image, so why can't we just do that for antiviruses? The antivirus is a machine learning algorithm that's looking at the static features of your file and determines whether it's a virus or not. So essentially, we could now create another artificial intelligence which goes, yeah, I'm going to take a virus and modify it so now it doesn't look like a virus. Does everybody understand that? Same boat? Cool. So why don't we just take the derivative between these viruses? Well, let's not do calculus. It's 4 o'clock on a Friday. Nobody wants to do calc. Plus, these viruses have tons and tons of properties. It's impossible to take the derivative between these things. So in Calc 1 and 2, you did the derivative of just dx, so that's just one dimension. In multivariate calc, you do dx dy, so that's 2 dimensions. And then we're talking about viruses, which have hundreds of dimensions. And you can't actually do that nice, and you would have to approximate it, and it gets messy. So we don't want to do calculus. Calculus has got a SAT on this Friday. So we're going to do genetic algorithms instead, because they're nice. They don't require any calculus whatsoever. And it's pretty much just basic algebra and a lot of the simpler ones. So that's got us feeling like a happy panda, not the sad panda. So who here didn't fall asleep in high school bio? Most? All right, about half of you managed that, so that's good. So for the half of you that fell asleep during high school bio, there's this thing called evolution. And essentially, the theory of evolution states that we have tons of things in this population. And over time, the more fit people for the environment will pass on their traits, and those traits will be observed more. And occasionally, we get these things called mutations, which changes things up a bit. And these changes may make us better. It may not. Who knows? So essentially, we have a population. It's composed of a bunch of individuals. Each person in the population has genes which represent different features of that individual. So with a genetic algorithm, you're exploiting this fact. So it's pretty much just making a ton of guesses, and the good guesses get to stick around and mix with the other good guesses, which may make it a better guess, but usually it's not a better guess. But you do this a ton of times, and you mutate, and you add new random things, and now you have an algorithm which could traverse a very large search space and converge on a relatively really good answer. So that's pretty neat. It's pretty simple. And yeah, you guys should check that out. So to make this a little bit more clear, I coded this JavaScript demo of a simple genetic algorithm a few weekends ago. So let's look here. So let's say we have 1,000 people in our population. Let's say we're going to take the top 10 people in the population every time. And let's start with no mutations. And let's not have any new organisms. So let's reset our population. So at the top here is our population of individuals. So they're just representing 2 different numbers. And our goal here is to correct the correct 2 numbers. So there's 2 numbers, and that's a correct solution, and we're trying to converge on that. So if we run this, we can see that we converged on the correct solution. And over time, our population got more fit, and we got the correct answer. So we could reset this. Let's say we want some mutation now. And we add some new people every generation. Let's see how that looks if we auto run it. So now there's a lot more noise because we're adding more random data to it each time. And that may look bad for a problem like this where there's only 2 genes, but in a high dimensional problem, which has potentially like 100 different dimensions, you really do want the mutation and new individuals to enter each generation so that you don't converge on a local minimum, but you converge on the global minimum. Does anybody have questions on that?
Yes.
Yes, Barry.
Why would we use genetic algorithm to converge on the global minimum when we can just do it on a local minimum?
All right, so sometimes you don't want the local minimum, and you actually want the global minimum. So a lot of calc-based solutions sometimes converge on the local minimum rather than exploring the whole search space and converging on the global minimum. All right, so now you guys know all about genetic algorithms. How can we use these things to make viruses? So there's really 3 big approaches that I came across when researching this the last few weeks. So essentially, the first approach is you create this virus factory, which takes in a list of properties. And these properties could be anything from the port of attack, how often it phones home, and other properties that these viruses may have. And essentially, what you do is you have that as your chromosome, and you slowly modify the chromosome to create your populations. So then, to evaluate the function of the chromosome, you run your chromosome through the virus factory, which creates a virus that you then run through all these antiviruses, which just so happen to tell us how much it thinks it's a virus. So based on the antivirus's response, it telling you how much it looks like a virus, you could then modify the chromosomes even more to make them look less and less like a virus. So you repeat that step, and eventually you might get lucky and find a virus which doesn't get detected by any of the antivirus programs. So that's pretty neat. So there's another approach which just applies polymorphic behaviors to the viruses and using this genetic algorithm approach. So essentially, this is a smart way of finding the best polymorphic behavior to apply to your virus to evade antivirus detection. Then there's also just behavioral approaches. So this usually uses something called, it's like the adversarial training. So it essentially plays a game against the antivirus to find the correct combination of behaviors, which will evade the antivirus, but eventually win the game. And the game in this sense will be behaving like a virus. All right, so that's how you could use it to evade antiviruses. There's also a ton of other approaches which we could use genetic algorithms. So a classic example is software fuzzing. So we could use software fuzzing to find inputs to a program which essentially break it. So that's pretty neat. And we could also use it to make images like Perry did, which for the antivirus. So not the antivirus, the image classifier. So essentially, you have each pixel of your image, which is represented by RGB, and you slowly tweak those values using your genetic algorithm to converge on a solution which gets classified as something else, but is actually something else, if that makes sense. So a lot of times, you end up with these very fuzzy images over here. So this is white noise, which humans would say, hey, that's just nothing, but the artificial intelligence would say, actually, that's a red shark, or that's a robin. But with genetic algorithms, we're actually able to represent images as genes, and using these genes, we're able to create images that look more realistic. So over here are some examples of that. So this image here, it classifies it as a baseball. So it doesn't look like anything to us, but it's white noise, so it's a bit better. And genetic algorithms could also be used to generate spam emails. So they do this by slowly tweaking the email until it finds the minimum number of changes required to make the email not get classified as spam. by the spam filters. So that's cool. So I just told you guys how to hack things with it, but to prevent this from happening, you would train it with an adversarial network, as we discussed earlier. And I really do see this being like the future of cybersecurity. So yes, Perry, what were you?
It's actually the problem of cybersecurity. If you go to Kali and download any software fuzzy to you, like American Fuzzy Loop, it uses genetic algorithm. That's why it's so fast. If you use like the stupid approach, it's going to take years.
So, do you guys have questions? At least one question? Nobody?
If you don't pay attention to this, when the robots take over in 20 years, they're going to crush your puppies. Okay?
Oh no.
You're going to crush your puppies and you're going to hack them, okay? That's why this is important.
Not my puppies.
Thank you very much.
All right.
As it's their first presentation, they get a lanyard. Wait, Perry. Would you like orange or gray?
Orange, yes.
All right, we're going to skip the formalities for right now. If they're still here at the end, then we can do the ceremony. But for right now, they just get the lanyards.
Thank you.
Oh, can I have a gray one?
Yes, you can. There you go.
Thanks.
Thank you very much. All right. So next up on the docket, we have the Collegiate Cyber Defense Competition team doing a recap for the Northeast Collegiate Cyber Defense Competition 2019 edition. They will be discussing what happened. So without further ado, as they make their way down to the front of the room, what? Actually, yeah. Rob, do you need to present right now, or can you wait until after they're done? Okay, cool. So without further ado, here is a portion of the CCDC team. They can't all be here right now due to other circumstances. It's gonna work. I bet it will work. You'll be happy if it works, aren't you? Yep.
It's not confirmed.
Ooh, it's gonna work.
It worked. It worked. It worked. Wow, think about that.
Not charging.
USB-C works across platforms.
Not charging, but it did work.
Because it's not plugged. Oh, it is plugged.
No, it's because of.
Interesting.
Why would you do this? Okay. Sorry, Nick. Sorry.
Yeah, I was there. But was not a competitor.
Russ, you want to talk or you want me to talk?
You're the cat. It's up to you.
I can talk.
All right.
Russ already presented.
I'll do my.
Russ presented. I already presented this.
I'll do my Windows stuff.
Yeah, what am I presenting on then? Did you make slides? I made a management slide.
Yeah.
Yeah, you made slides.
Yeah.
Oh, fuck.
You're fine.
All slides you made, you just talk.
All right. Who else is here that isn't out here? Is this everybody? This is everybody.
Yep, this is everybody.
All right. Do we have to prepare this?
Where's the... Yeah, you need that. That's a nice stream.
So we're just gonna like.
Yeah, just hold it.
Yeah. All right, we're just gonna hold this mic so it's a little easier. Oh my God, that was loud. So we're just gonna give you a recap of basically what happened in the competition. For those of you who don't know, we came in first. Woo! So we'll be going to the national competition in Orlando on April 23rd, which will be awesome. And then we might give another presentation after that. We'll see how much time we have. But we thought we'd do this just so anybody who's interested in CCDC knows kind of like what you would go through during the competition and basically what we do as a blue team that might be specific to us that could help other blue teams for other competitions in the future, like RITSEC. So, without further ado, basically the general theme that they gave us this year is that we were a DevOps team for a company called Storm Surge Software. And so This is pretty funny, actually. Champlain, the college, their logo or their mascot is the beaver. So the domain we had was beavernado.com, kind of like Sharknado. That was kind of funny. We got a kick out of that during the competition. And basically, we were supporting the Canvas learning management software, which is a web application, kind of like My Courses, and it's actually used by legitimate schools and institutions. So that was kind of interesting, and it's fully open source. And they were really pushing resilience and recovery throughout the competition. So that's like disaster recovery. What happens when your services go down? Do you have backups? Do you have replication for your databases and stuff like that? You're next.
Okay.
Yeah, we're going to rotate.
All right. Jeez.
Yep.
All right, so here's some buzzwords for you guys who maybe kind of haven't heard of CCDC or are just new to these competitions in general. So the first is injects, and injects are just like business tasks that like are given to you throughout the competition. So these are, could be anything from, hey, write some policy on a disaster recovery plan. So, if our network goes down, we have something in place. Or it could be, hey, something like more technical, like, hey, set up PKI infrastructure. Next is scored services, which is going to be like pretty much, like one way you're scored is you're scored through injects. And that was 50% of the scoring for this competition. But services are also, like service uptime is also another way we're scored. So that is the other 50%. And, red team is obviously going to try to take these down and lower your score. So keeping them up throughout the competition is really important, and it kind of will increase your score as the competition goes on. So I believe we placed first in scoring, correct? Yes, we placed first in scoring for service uptime, so that was super awesome, and we did a great job with that. Anyways, moving on, white team. White team is going to be the people who basically help with the competition. They also help set up the competition. They're kind of like the all hands on deck. They do a lot of different things, and usually volunteers, so it's really awesome. Orange team is going to be basically end users. So this was kind of a new thing we hadn't seen before, at least I hadn't. They implemented like an orange team that would pretty much was the end users and people that were either affected or need to use our services. So, and then black team is basically like the infrastructure leads, and they pretty much run the whole competition and set it all up and pretty much have their hands deep in all the infrastructure, ESXi, vCenter, stuff like that. And then we have finally the red team, their team, the group of people who are trying to take down our services, trying to cause downtime, and basically testing our abilities to respond to incidents around the network and keep our services up and manage everything. So.
Hey, Ross.
Hey, what's up?
Please attach the mic to your shirt.
We're going to be.
I don't think we can hear it. Okay, then hold it higher.
Okay, sorry. My bad. Okay, anyways. Moving on. So our topology. Simon, do you want to talk about our topology?
Yeah, you two talk about this, and then we can go in and out.
Okay. All right.
We got a lot of like general slides.
You're cool.
All right, so this was the topology that we were initially given, and thankfully it turns out it didn't change too much on competition day. So it's not unheard of to be given a topology like this, and then they kind of change it up on you. So right here we have our Canvas box all on its lonesome in the DMZ, and then all of our other boxes in the LAN. And something interesting you might see in the LAN is we actually have a wireless access point. So that was kind of they kind of threw a stick in the wheel with that because we didn't have enough Ethernet cables to actually put all of our boxes on our wired network. So we also had to manage uptime with our wireless network, and Red Team was trying to hit that as well. And so it was all just a big mess, but we made it work. And we also had a client outside of our network on the WAN, and this was simulating a business user that was, VPNing into a corporate network and trying to access services. So if they couldn't access our VPN or anything, our CEO would come in and get upset because their workers couldn't work remotely. Do you want me to do this one too?
Yeah.
Okay. So this is the plan we came up with / what we ended up with by the end of the competition. As you can see, we moved some boxes around. We have our Hyper-V up there in the top right. We actually migrated and created new virtual machines to put services up there so we can kind of isolate them a little better.
And we actually moved the server, the Windows server, off of the Wi-Fi, because who puts a server on Wi-Fi? That just doesn't make sense. Don't ever do that. So we moved the Windows server off the Wi-Fi, and we moved that Workstation 1 client, which wasn't scored, by the way. That was my box, so that was fun. We moved that onto the Wi-Fi because having the server, on a wired, reliable connection was much more important than just a workstation. And then poor Jack, he fought with Canvas the entire day. He did a great job, but Canvas was being real mean to him.
Oh, I'm up again.
Here you go, buddy.
Okay.
Hold on, give me a sec. I feel like we missed a slide. So just let me, somebody deleted my slide.
All right, ignore this slide. It's not here right now. The slide that's actually up on screen is to introduce a team. And so our team, if I can do this by memory, was Brandon Adler as captain, and he was the inject lead. I was co-captain. I was on the domain controller. We had Simon. He was our networking guy on the Palo Alto. We had Connor, who was on Windows clients / just Windows, general Windows stuff. We had Jack, who was our Linux lead, and you just did Linux stuff? I don't really know.
Yeah, just Linux stuff.
That's the best I got, okay. All right, now from memory, we had Duck, also on Linux, helping Jack with Linux stuff. We had Amanda doing Windows clients, and she helped a lot out with Injects, which was super awesome. Amanda Brown, who else? Newman, who was also doing Windows and mainly dealing with the Hyper-V service. And who else? Am I missing anyone? That's everyone, right?
That's Philip. Philip was an alternate.
Oh, okay, yeah, alternate. So we had Philip, who was an alternate, who has the blue grill in the front. And so Philip was an alternate, and they were a huge help overnight. We also had Robert as an alternate, and
shout out to Robert. Not here right now.
Nick was also super helpful throughout the weekend as well. Yeah, Nick and Joe, our assistant coach, all super helpful throughout the weekend, helping us keep us calm and giving us good advice. And Bo was also our coach, who was super helpful. Drove us down and bought all our meals and fed us, kept us happy. So
yeah, it was nice.
Yeah, so shout out to everyone on the team. They were all super helpful. But anyways, on to Windows and Active Directory. Mike, I have to do it. I'm just gonna, because I'll forget. Okay. Anyways, so Active Directory, I was on the domain controller. And so this year, we actually had kind of like a best practice sort of setup where the domain controller was actually a Windows Server core, which is a big yikes, in my opinion, for CCDC, because you don't have a GUI. And a lot of the Active Directory things you have to do require a GUI or just like really hard without one. So I definitely had to step up my PowerShell game quite a bit for like my initial plan. And but we still treated it like it was best practice, right? Like, we still, eventually, once we got everything kind of set up, like firewall rules, we create backup users, change passwords, stuff like that. I eventually moved to the management box to administer like the Active Directory environment because it's just really too hard. Like doing GPOs and managing users and stuff is kind of difficult through PowerShell. It's just a lot slower and it feels a lot more like tedious. So that's what we kind of did for our plan. Overall, it worked pretty well. We implemented some like whitelisting for DNS that worked really well and stopped all like Red Team's DNS beacons. But they, their initial persistence in the box was pretty heavy. They had plenty of like fake accounts with domain admin privileges that we had to go through, and they had some fake services as well that probably were using Cobalt Strike to call back. So, but again, the DNS whitelisting helped a lot, and we also had a Squid proxy, which I'm sure Jack will talk about a little bit, but that was HTTP proxy that helped us too. So that way HTTP beacons couldn't get out, so that was super good. I would think of another slide. Yeah. So on the inject side of things for Windows, they really, really hammered home PKI, which was super cool because I had never done PKI before, so I learned a lot about that really quickly. But also super not cool because there was a lot of PKI. So, and this became like a big challenge as well because in the middle of a competition, they, on the second day, they actually decided to take one of our boxes from us, which was the management host that Connor started off on. So, yeah, and he'll talk about that in a sec. But that became a big problem because there was less hands on the keyboard at that point because we had one less computer, and that meant it was harder for us to actually administer PKI, do the injects, and administer the network or the domain. So we actually migrated to Hyper-V and put another domain controller up on Hyper-V to actually administer it from there. So, but we actually did that before they took the box, which is super lucky. So we had like no downtime with the management box, which was awesome. So that was a really great big plus for us. It helped us out a lot. Yeah, but overall, the PKI injects were probably like the biggest challenge throughout the whole competition for me, because I was just like, I didn't know what CERT, what was it, CRL, CLR? CRL, yeah, cert revocation list. I didn't know what that was, and then they're like, yeah, develop a CRL. I was like, hey Brandon, what's a CRL? So that was, but it was really great for me to kind of get that experience and kind of be able to think on my feet like that. So yeah, that was super cool. I really enjoyed it, and it was a good challenge. But I feel like Windows, we did really well overall. So. And Connor will talk about the management side of things on his box.
Hello. Is this working?
Yes.
Cool.
So that goes to the stream. That goes to everybody else.
So I need to do both. I'm trying. I'm
Just
trying.
stand
I'm
here
trying.
and just talk.
Talk.
Hey there. We're gonna do one of these. There you go.
Thanks. I haven't given a presentation here yet before.
Oh, he's got to get a lanyard.
Heck yeah. Thank you. I appreciate that. Thank you. So I was on the management box. This was initially on the wireless, and that was a big pain because it was our IIS server initially. Who puts a web server on the wireless? What we did with management is kind of installed some remote system administration tools so that we would be able to connect to our Active Directory domain and administer it through MMC or through some built-in like group policy. You can just kind of connect to your domain controller through that. One of the first things that we did with management after moving it off of the wireless was we promoted it to a domain controller, and we set up like replication between DC1 and management, which then kind of became DC2. That was done as an inject, but it was kind of our plan going in to have multiple DCs anyway, because they were really pushing for redundancy and resilience and disaster recovery. And what's more disastrous than losing your domain controller? And that's actually exactly what happened. After we set up DC2 on management, we spun up another DC on the Hyper-V box. And yeah, so we had three domain controllers. They came in, they took my management box. Was that day one or day two?
That was day two.
Day two. A little bit into day two, they came in, they took my laptop, and I didn't really have a laptop. I was a floater. I jumped between other Windows boxes and actually some Linux boxes for a little bit, trying to do research and write injects. Because injects, I think
we covered it,
yeah. Yeah, one of the, or multiple injects were kind of research paper style things. And it's hard to do research on something that you don't know if you don't have internet or a browser. I can't just wget pages if I don't know what they are. So with management, they only score the default website. Like you start up IIS, and they probably like grepped for IIS server manager or something. So that meant we were able to migrate IIS to Hyper-V. And at one point in time, I got management back. They brought back a new laptop. It was Windows 10. We wiped it. We installed Server 2016. And I spent like 20 minutes hardening that. And then they took that box too. Yeah.
Yeah. Real quick, I forgot to talk about this, but yeah, they came in, and when they took management again, first they came in. I don't know if you're here, but I think you're working on something. But they, yeah. The guy came in and was like, "Hey, we need we need a box. We need to take a box." And we were like, "You already took our management." And he's like, "Okay, give me your other your main domain controller, like DC1." I was like. I froze because I'm like, oh no, if they take our domain controller, we're screwed, right? And then thankfully the black team member was like, no, don't do that to them. So then we just gave them back the old management box, which is thankfully that saved us, because if they would have taken our main domain controller, that would have been a big that would completely been a disaster. That would have been an actual disaster.
Would not have been a fun time. Yeah. So after we got management taken for the second time, which was hardened DC, they brought it back, thankfully. This was very kind of them. Really appreciate this. They brought back an XP box. When you opened it up and started it, it auto-logged in. There was redteam.exe running. The mouse was like 500 times the size. It was a mess. So we just turned that box off, pushed it off to the side, and we were like, OK, whenever we get a free 30 minutes with our flash drive, we'll re-image the box. And we never got a free 30 minutes with the flash drive, so I didn't have a laptop for the last few hours. So that was cool. For IIS on management, the site kept getting defaced. I tried to figure out what was going wrong with it. I set up Procmon. I set up some filtering that only filtered on the website, like the HTML file, because the HTML file would be overwritten with like red team defaced this site kind of thing. But we couldn't actually find what was changing the website, even though I was checking file or create file, modify file, like open file, all the different file operations that you can do in Procmon. Couldn't find it. Turns out it was like a driver. And I have no clue how they did that without anything registering in Procmon, so that kind of sucked. And we just migrated IIS, actually. Since it was the default site, we could just spin it up on Hyper-V. Speaking of Hyper-V.
Yeah, I can talk about Hyper-V since Newman is not here with us today. So basically, the Hyper-V box, if any of you have dealt with hypervisors like ESXi or even VMware Workstation, it's kind of like that, right? Except it's Microsoft. So what does it run on? Windows Server. Who wants a hypervisor to run on Windows Server? Nobody. So thankfully, this actually had a GUI, which in production they shouldn't. So realistic, question mark. Managing it with PowerShell is honestly pretty easy. You can do some things in PowerShell that you can't do in the web GUI. And likewise, you can do some things in the web GUI that you can't do in PowerShell. So that's always fun. So you got to kind of have both. Like to console into a VM, you actually need a computer on the domain to connect to Hyper-V to get the console. You can't do it from PowerShell. You can't do it from a client not on the domain. You can't do it from a Linux box. So that kind of sucks. So that we had like 3 boxes we could use at one point to log on to Hyper-V, but then when they took one, we could really only do it from Hyper-V. And yeah, exactly. So providing the VM consoles to actually set up VMs and configure them first off was kind of annoying because we didn't totally want to open SSH to the red team in case they had something on Hyper-V or had something on the VM that was already on the box. So several people at one point needed to get on the VMs on Hyper-V, and we basically had a queue set up of people waiting for who needs to access their VM next. So that was kind of a problem during the competition. Thankfully, it was only scored on ping, and it wasn't originally connected to the domain. So we only, in the firewall, we only allowed ping in and out. And then when Newman had to go out and get an ISO or something from the internet, he had to set firewall rules up for his browser to get out of the firewall, which you can do in Windows. Awesome. Highly recommend for blue teams. Whitelisting applications instead of just allowing every application out to port 80. Lifesaver. And so that's basically all we had coming in and out on this box for most of the competition was ping. Because from a red team perspective, if you were able to get on a blue team's hypervisor, you're golden. Because once you're on, you can turn off VMs. You can theoretically modify VMs, and you can take down the whole hypervisor, which could be up to 7 scored services. So that would have hit us pretty hard if they took that down. So I already talked about ping. As we were previously saying, due to our firewall rules, the red team activity was pretty limited. At one point, our box actually restarted because when Newman had his firewall rules more open, since he was connecting to the internet, it just happened that one of the red team implants on the box called out to the CobbleStrike server, and it got a command to restart our Hyper-V box. So when it first restarted, it kind of looked like it was updating. The blue rectangle came up and said, we were installing updates. We're going to shut down in a minute. And he was like, this isn't good. And then when it restarted, it just went black. Like he shut off the power button, but he didn't actually do that. So he knew something was pretty weird from that. And later, we verified that that actually was red team activity. So thankfully, they didn't do too much and just restarted our box. Yeah, and so red team actually had another thing that they were kind of using to troll all the teams. So if anybody of you know, like they had a GIF of a dancing banana, peanut butter and jelly time, the dancing banana from Peanut Butter Jelly Time. They had like 10 of these that popped up on your screen, and they just danced while you were trying to do stuff. So it hit a couple other teams, and they showed it in the red team debrief video. And honestly, it was pretty funny. Lucky it didn't hit us, though, because that would have been super annoying. Splunk. You want to talk about Splunk? Awesome.
So one of the things we totally missed when we were preparing is that Tom Kochak is on the red team for NEC CDC, and he works at Splunk. And actually last year at B-Sides, he did a Splunk workshop that some of us had gone to. Anyways, we didn't realize he was on the red team. And so when we were preparing to do logging, we were assuming we were going to build our own logging infrastructure. So we spent a lot of time practicing with Graylog. Minute 0, we get to Hyper-V, turn it on. There's a Splunk VM. And Newman and I started crying. Splunk is great. We just hadn't printed out the materials to set up our Splunk infrastructure, which is what we did last year. Day 2, we came in with printed how to Splunk. But day 1, we were a little we should have thought about that. That was oversight. Anyways, we got there. It was already installed. They pwned it pretty quickly. Our first inject was to set up logging on Splunk. And we had prepared and gotten really good at setting up logging for Graylog, but I think they gave us 30 minutes, and they're like, all right, everything in your infrastructure, log to Splunk. Did not happen, not even a little bit. I think we logged into Splunk at the end of 30 minutes. So that was rough. It also took us by surprise that was the first inject, because historically it's always been a inventory inject where you fill out a bunch of papers and say, this is the boxes we have on our network, but there wasn't any inject like that. So there was a couple surprises, which was good. Yeah, so they stopped our scoring by changing the UI to say managed by red team, and then stole our passwords. Docker, this is what Duck Fan worked on. He's not here right now, so I'll talk about it. But our CentOS box was originally going to be a virtualized box, and then before the competition, they moved it to a real box, which was great, because we didn't have to run BSD on bare metal, and that was the best thing that ever happened. Thank God. So yeah, only ping was scored. It took Duck about 2 hours to figure out how to log in. We got to talk to one of the red teamers afterwards, and he had dropped a PAM backdoor. And what he didn't realize until after he deployed is that the PAM backdoor broke a lot of things when you tried to log in because of SE Linux. And so when you tried to log in, his PAM backdoor tried to do something that SE Linux was blocking, and so all login just failed. And so Duck spent 2 hours in single user mode trying to figure it out, and eventually he's just like, all right, we're getting rid of SE Linux, and that fixed it. He logs in, he's like, well, 2 hours behind now, and red team's popped everything. Better bring up scoring. Luckily, it was only pinged on ICMP, and after that, well, that box was pretty bodied the entire time, actually. Red team was pretty much in, and they owned it by after the first 2 hours, so we ended up migrating everything off of it and calling that one a day. Okay. Yeah, so part of that, we also set up our own proxy and DNS server in the cloud. They were clean VMs, so the only way to get to them would have been if they had already infected the Hyper-V server and were somehow injecting into the boxes. And this was just to prevent callbacks. Some of the more advanced callbacks, like DNS callbacks, Simon just applied a block all rule so that the only thing out for DNS and HTTP was this server. Yeah, so we had one BSD box. It was virtualized when we got there, which was fucking awesome. PF is awesome, according to Duck. Yeah, he's a big fan. But anyways, we got an inject for it. We had to install a Git T server, which is a Git subversion system. It specifically said to do it on the BSD box, which kind of sucked, because normally we would just install it on something else and make it super easy, but oh well. Yeah. Canvas. So this is the box I spent all of my time on. Hour 1, our database got dropped, so that was either my fault or Red Team. I'm pretty sure it wasn't my fault, but like, if it was Red Team, that was really rude because that was hour 1 and our service just went down. Anyways, luckily in the 5-minute plan, we made a backup of it. We had 3 databases with the content of Canvas running at one time. We had one in Docker, one in the CentOS VM on bare metal, and then one in a VM on the hypervisor. And so we had a lot of redundancy in terms of the database. So that check didn't ever go down. The only problem was the actual Canvas box takes about 30 minutes to migrate, ideally. However, in the process of migrating, I had very limited internet, and then my tar backup was corrupted, so I wasn't able to pull out the compiled assets, which meant that I had to recompile everything, which usually takes about an hour and a half to do from start to finish. So we had 2 half-working Canvas boxes, 3 databases, and very little scoring on that box.
Here's your little Mikey. Thanks, buddy. Yeah, I'm sorry about Canvas. Yeah, it's okay. All right, so I was in charge of our networking and everything. So I actually got to play with a Palo Alto 3050, which is kind of cool because it's a multi-$1,000 piece of hardware. So I'll probably never see one again except at Nationals. So that was pretty cool. Also, the cool thing about physical Palo Altos is those things are like fortresses. So like the only way that I'm aware to actually access the management of them and actually, do things to the configuration on a physical one at least is to plug in a console cable into the console port and then, use PuTTY or SSH or whatever, or plug an Ethernet cable into a management port, and that allows you to access the web GUI. So thankfully, Red Team, couldn't hit those unless they walked into our room and plug in, which I'm pretty sure they wanted to at one point. And we also had the Wi-Fi isn't on here. But yeah, so yeah, 1 management port. Everything was hooked up to a switch and then to our router. But unfortunately, our switch was out of scope. But Red Team did do some nasty things to our switch, which was not nice. We also had a tiny little access point. I almost didn't even see it whenever we were in the room. And it was running OpenWRT, which is like an open source, just like a router application firmware image that you can use. And fun fact, Red Team actually, or one of the Red Team members, Silas Cutler, actually wrote a custom firmware image to backdoor our wireless router for all the teams. But for some reason, we didn't have it, because later on in the day, my CEO, the Orange Team CEO, came in with him as an FBI agent. And they're like, your access point has been backdoored. We need to check it, blah, blah, blah. So he checked it, and it was clean. It was fine. But I have no idea how that got cleaned. Probably I reset it 6 to 7 times in the beginning because, I don't know, I kept typing in wrong numbers or wrong passwords or something. So must have updated the firmware somewhere in there. I have no idea. But at one point we did actually see, or I did see a Red Team member log into our Wi-Fi, and we saw them sitting out in the hallway. He was making his way around to all the rooms. So that was pretty cute. He couldn't do anything though. So here's some tips for you blue teamers at any competitions that you might go to. Bottlenecks. All right, so your network layer and your firewall and everything, that's going to be one of the most important places and the place where you can really lock Red Team down and not allow them to go, because if they can't get their traffic out, they can't do anything to you. And if they can't pivot, they can't do anything to you, right? So one of the ways we did that, and it's been mentioned already, is we had DNS forwarding. So we spun up a bind server, and then we pointed all of our boxes DNS to that box, to that forwarder, and then that forwarder would then forward our requests out. Okay, so that means if they had any DNS callbacks that were trying to just go straight out to like quad 8s or quad 1s or whatever their custom ones were, they just wouldn't work because their applications and malware weren't set up to go to our forwarder. And the same thing with our Squid proxy. Squid is actually the name of the application that you can download, so you can do like yum install Squid, I'm pretty sure is all it is. And that's basically the same thing, but it's for your HTTP traffic. So you'll send your HTTP request to the Squid proxy, and then the Squid proxy will, proxy them away to wherever you wanted your request to go. And this does the same thing as the DNS forwarder, and it makes it really easy to log all the requests and see where all the traffic's going, because you won't be able to see any pivoting on the LAN segments from the router. So I could see all the traffic trying to go out and trying to come in, but I couldn't see anything going on our internal. So that was up to the clients to log. So this really helped with that. And also, this took like 5 minutes to set up. So before your competition, take like 30 minutes to read up on both of these things, like write down on a piece of paper how to do it, and then come in. As long as you have internet to download the packages, which might not happen, you can get everything configured, typed out in like 5 minutes. It's really, really easy. Well, that's about all we got. Does anybody have any questions? You guys have anything else? No? Yeah, what's up?
Why do you think you did so well this year?
Oh.
I don't think I did so well. So it definitely helps. So I know last year we had some issues with more or less custom scoring checks that White Team did. So this is for our AWS infrastructure. So basically, if anybody of you know like AWS and know what tags are in AWS, they had a tag set up on our EC2 instance that they had a script that queried the tags to set its IP in Route 53. And we destroyed our EC2 instance, so the tag wasn't there, so the script broke. And then when we spun another one up, we were like, why isn't this scoring? It's because they were doing custom scoring checks. This year, there was some scoring problems, but they were pretty much resolved an hour into the competition. So it wasn't like too big of a deal, but it definitely helps to have a white team and black team that knows what they're doing and knows exactly how to fix things if they break, if they're doing custom checks anyways.
I have something to add if you're done. Okay. Also, like I just mentioned, I think a big part of our success was those bottlenecks that we had. Because one thing I did forget to mention is by the end of the day, Jack said that I had put the block all DNS requests and I had a default block all rule on our Palo Alto. By the end of the day, the block DNS requests that I had alone was over 200,000. Okay, so that kind of gives you an idea of how much these guys were beaconing. Now, some of that traffic was probably ours because people did forget to change their forwarding address. But that just goes to show you, if you have good firewall rules, and you bottleneck your stuff, and everybody communicates, and you guys just all work together, like you can really lock Red Team out.
And one of the coolest things about locking down the network strategy as well is that we don't care if there's malware on our systems. We don't care if there's beacons trying to get out to their C2s that are still calling out from our systems. As long as they can't get through our firewall or don't have a time bomb set to say after 30 minutes of not being able to reach out, I'm going to execute this command, then they literally can't execute commands on our system, and they really don't have access to our systems at all. So try to think about it in that mentality too, not just like clean my system, but how can we prevent the beacons from pivoting and from getting out of our network entirely.
I think also a big thing that we did to really help us, which I talked about briefly, was like migrating. Like the one box Connor talked about had like literally a driver on it, and that would have taken us like ages to find, just because it's signed, and drivers are really hard to pick out from what's legit, what's not, because you can just name it something like Microsoft, blah blah blah, and it's like, oh, this is cool. So yeah, I think like being able to migrate and like have that redundancy throughout our network was like super awesome, and like kept our services up. And when they took the management box, we saw like all our team's services went down because they didn't have their IS server anymore. They weren't prepared for it. But like we already had one set up, ready to go, so like it was not a big deal at all. So that was huge. Yeah. Cool. All right. Well, thank you guys very much. Appreciate you guys listening.
I need one. I want to hear it. Easy.
Yikes.
All right.
Hey, Micah, you want to cue up the song?
Do you need on here?
I don't. My laptop's up there. So.